As a programmer, it is increasingly frustrating to pick up a code base to find failing unit tests, messed up config files, missing dependencies, misaligned packages, compile time errors. Now, wouldn't it be great if the programmer who worked on the code base before you had sorted all these issues out? But genuinely, if you go and talk to them, they'll tell you that they didn't do this intentionally. It just worked on their machine. Now, wouldn't it be great if there was a way of taking every code change and incrementing it on a server that wasn't the developer's server, compiling it and running the unit test, and that will help highlight if there are any issues in the code base. That practice is called continuous integration. But continuous integration needs that you have a source control system in place. And just like all other practices within DevOps, and we're going to look at that in the pipeline that you can see on your screen, whether it's automated builds, automated deployment, automated tests, and all of these are practices that elite IT organizations would use, require source control. More so today, we're at a point where everything's turned into code, whether it's database, it's infrastructure, it's security, it's policy, and more so now process. Now, with all of these things turning into code, you would not be able to achieve continuous delivery if you did not have a source control solution in place. So for me, code does not exist until it's committed into source control. If you don't have a source control in place, that's almost like saying you don't have a single version of truth for your software. Now, there is a wide array of source control solutions out there in the market. Start off with a Google search and you'd be overwhelmed with the number of responses on products that you get. But most of the source control systems can be bucketed into two categories: centralized and distributed. Now, centralized version control and distributed version control both have their own place, and we're going to discuss the differences between the two. But I want to highlight a little interesting trend that I observed the other day. I was playing with Google Trends. Google Trends is a service provided by Google where you can go and look for search keywords historically over the last 10, 15 years in specific industries. So I did a trend analysis on centralized and distributed version control systems over the past 10 years, looking at IT industry specifically. And as you can see, the blue line, which is the centralized version control system, was really at its very, very peak when waterfall was the de facto for any project delivery. Whereas with Agile making an appearance, distributed version control systems started gaining more traction. And more so in the last 5 years or so, with open source taking the front seat, distributed version control systems have become mainstream. Now, I don't want you to take this slide as a way of me telling you that distributed version control systems are the way forward, but I am just looking at this and trying to highlight a trend that's happening in the market at the minute. So what is a centralized version control system? Well, a centralized version control system is centralized. There's a server somewhere that everyone needs to connect to. It is that server that has all the code and its history and its artifacts stored centrally. So if I want to work on that code, I need to download a working copy of the code. Now, the working copy does not have the history of the code. The history is stored centrally on the central server. But every time I commit or change a file, I basically send a request out to the central server, which checks out the file or commits the changes that I've made. And if someone else is trying to edit them, then the server knows that two people are trying to edit them and highlights that two people are trying to edit the same file. Now, as you can almost make out already, this kind of a version control system is best suited when you have really large code bases and you need more granular control on who can access what file, which type of file can be exclusively checked out or checked out to everyone, and you want to monitor and audit individuals that are accessing certain file types. This source control is also well suited for file types that are hard to merge. Like a few years back, if you were doing BizTalk and SSIS, it was very hard to merge those code bases. You literally had to overwrite the changes from one branch to the other as you were merging. And for those kind of scenarios, centralized version control systems are best suited. Now, if we talk about distributed source control systems, the secret's in the name, it's distributed. There is no central one server. Every node in the chain carries all the history of the changes, which means every node in the chain can become its own server. Now, distributed source control systems can work in a centralized fashion where you create a central repository remotely and let everyone else access that. But when you download a working copy, unlike centralized version control systems and distributed version control systems, you download all the history along with you. The benefit of that approach, obviously, is you can work in a disconnected fashion. You don't need to be connected to the server to look at the history, make changes to the files, commit them. You only need to be connected up to the server if you want to push your changes to make them available to everyone else. The biggest benefit of Git is it's cross-platform. It works on Windows, Linux, Mac. It was invented in the open source, and it's been innovated in the open source. It's got a huge user base behind it, a very enthusiastic, growing user base, which is constantly helping bring new changes into Git as a platform. Now, Git is best suited for smaller code bases and modular code bases. And the reason I say that is because when you are downloading all the history with you, the additional history may slow you down if you have a very large code base. Therefore, if you're looking at creating really large code bases, then I would err towards centralized version control systems. Again, Git is for highly distributed teams. It's great for teams that are working across platforms. And it's fantastic. If you're kicking off a new project, then I would encourage you to start with Git as your source control system. So in this video, we broadly covered why source control system is an absolute must-have to do any DevOps. What is the distinction between distributed and centralized version control systems? And we briefly touched on a trend that's happening in the market, which is highlighting that the uptake on distributed version control systems, and more specifically Git, is on its all-time high.